The test. Uh, so sorry, man.
Can you hear me?
Yes, sir.
And
Yes, sir.
we will just start in one more minute. Meanwhile, are there any doubts from what we did last time? So we covered the topics of equations of acceleration, conservation of energy and momentum, and the last topic we did was density and buoyancy
Sir,
for
I have a
fluids.
doubt in density and buoyancy.
Yes, go ahead. So you have a doubt about the questions or about the theory? Like,
About the theory, sir.
Okay, okay, tell me. Do you have any specific question, or you want me to uh, talk about the general concept?
General concept, sir, I want.
Okay, okay. Then while we are still waiting for the class to start, maybe just to quickly go over what is buoyancy, why does buoyancy exist, like in the first place? That is itself a question that is worth thinking about, that why do liquids have buoyancy? So the reason can be explained in this way, that basically any liquid has particles, right? You know, they're atoms and molecules, and those atoms and molecules uh, keep moving around. So the property of a liquid versus a solid object is that in a solid object, all the atoms are in a fixed grid-like structure. So they cannot move. They can have small movement at the local position, but they cannot move freely in the container. Whereas in liquid, the molecules can freely move. And so if there is some object which is there in that, right? So what will happen is that the particles of the water or water liquid, they will collide with each other, they will collide with the object itself. And so basically they have at different parts of the object, they will exert their force, like in this way. Okay. And the sum total of all these interactions is what causes the buoyancy. So in general, like the net effect of, if we add up all the forces, the effect is as if the object is being pushed upwards. Okay. And that is what we call the buoyant force. And the magnitude of the buoyant force only depends on how much liquid is displaced. So what do we mean by displaced liquid? That, you know, because of the object being submerged, there is some amount of liquid, like the volume of the part which is it is occupying, right? So that volume is the only thing that matters. So the buoyant force is given by, so last time we derived this formula, it is a gravitational acceleration into the density of the liquid into the volume of the displaced liquid. Okay. So in other words, in this diagram, for example, this red cube, that is the volume of the displaced fluid. So the actual object can be, can be as large as possible at the top. That doesn't matter. What will only matter is this part. Okay. So this is what the buoyant force is. And typically, like any object will have its own weight also. So when the object is floating, the weight and the buoyant force are perfectly balanced. And from that, we can calculate some equations that we did last time, that like what is the density of the relative density of the water, the liquid and the object can be related in this way. And generally, we'll solve any questions using this concept. So, I mean, the only sort of important formula is this one actually. Everything else can be derived from that. Okay, but as I said that we don't have time to go into a lot of technical detail. This is a very much like a focus towards problem solving. So, explanation of why buoyant force acts this way and lots of other things we cannot cover in this very short session. But I hope that with you're able to apply this concept and solve the problems. That is the main focus for us. Okay.
Okay, sir. Thank you.
Yeah. Okay. And yeah, if you have any theoretical questions about this, right? I mean, honestly, these days you have so much learning material available online. You have, textbooks, even YouTube videos. Like any doubts that you have in terms of theory, you can ask your teacher, or you can try to get some help online. So that should not be difficult these days. Uh, yeah. Sorry. One more thing to say before we start discussing the problems. So today we will finish discussing all the problems of the last paper and the previous the two papers that we were planning. So then what to do after that? So I am actually going to give you one practice paper after today's lecture is over. I will post the PDF on our WhatsApp group, and you are supposed to solve that paper. It is just the physics part of it, right? So imagine that your total exam is of 3 hours, and out of that you have 1 hour for physics. So I'm going to send you a paper with 10 physics questions which you are supposed to solve in 1 hour, and they are exactly of the like this exam format, that the answer is going to be 2 digit, like the answer you have to be right between 00 and 99. Okay. You have the full day tomorrow to solve that paper, and then tomorrow evening in the last physics section we will discuss that the answer key and hints of this paper. But for what I will suggest you to do is do two things. Okay, first solve the paper in the first attempt with time limit. Okay. Okay, which means that imagine that is actually an exam. So by the way, don't open the PDF immediately after I send it today. Only open it when you are going to start writing the exam. Okay, so give it the proper like treatment of an exam. With a fixed 1 hour time, try to solve the paper and see how many questions you are able to solve. After that, again try a second attempt, but now this time no time limit. Okay, so now take as much time as you need to solve each question. And this is something else that we are checking that. So the second question is about, is your theory well understood? That do you understand, if I give you enough time, are you able to solve every single question? Okay. So ideally, if your theoretical basis perfect, then this second no time limit, you should get 100% correct. Okay. Uh, if you are not getting this 100% correct, it means that you need to revise your theory or learn the concepts again. But maybe somebody is able to do with no time limit very well, but with time limit they are struggling, which means that the for them what is more important is the exam practice. Okay, so there now, if that is the case, then you need to spend more time to develop formula sheet or things like that. So based on these two categories, it will help you to judge that how am I doing about the theoretical aspect and about the exam pattern solving. Okay. And finally, for JEE, both will be important, of course. But before that is during the very last phase of your JEE preparation. But for the 2 years before that, like your 11th standard and I would say at least first half of 12th standard, your focus is going to be on the theoretical part. That forget the time limit. Are you able to solve the questions? That is the first thing. Okay. But yeah, slowly as you approach your JEE, your focus will shift from the just the theory to the application also. Okay, so for tomorrow's paper, try these two things. Okay, try with time limit and then without time limit. Okay, and then we'll discuss the questions tomorrow. Okay. So yeah, that was about what we're going to do tomorrow. So coming back to what we are going to do today. So I'll continue with the next questions. So the topic that we are going to look at now is electricity and electric charges, specific no, not specific, what you call equivalent resistance, things like that. Okay. So we'll start with this question. Uh, so first, before even we do the question, I hope the basic formula everybody knows that when you have two charged particles, right? So the force between them is given by this equation. So the force is given by, there is a Coulomb's constant, we typically denote by capital C, and then the charges, let us say the charges are Q1 and Q2, and divided by the
D
distance
square.
square. So how much is d square, right? So this is an example of what is called an inverse square law. Okay. So as the distance doubles, the force will become 4 times weaker, right? So it is related to the square of the distance. And then what is the sign of the force? Is it attractive or repulsive? What is the condition for that?
Like poles repels and unlike poles attract.
Yes, correct, right? So if both are positive, then the force will repel, or if both are negative, then also it will repel. But if one is positive and one is negative, then the charges will get attracted. Okay. So accordingly, the sign will get decided, positive or negative. So this is all you need to know, honestly. So for this question 14 and even the other next question, if you know this and you apply it, you are going to get any question of this type. There is nothing more to be, considered. So with this understanding, if you look at the first question, so what is given that there are 3 points ABC on a straight line. So, and I think the distances between them are given. AB is 10 centimeter and BC is 20 centimeter. Okay. And then some scenarios will be given. Like the first scenario is that there are charges placed at point A and point C. Okay. So at point A, a charge of plus QA. So this is a positive charge. And here it is plus QC. So both positive charges. Okay. And at B, there is a negative charge. Okay. Okay. And it is given that the total electrostatic force on B is 0, which means, so if you see here, who is going to get attracted? So B is going to get attracted towards A and C, right? So B is going to get pulled by both directions. And what is being told is that total sum of these forces is 0, which means that these forces have to be of equal magnitude, right? So if I just find the magnitude of these two forces, they should be equal. So on the left left one, how much the force is going to be? It is the Coulomb's constant times the product of the charges upon the distance square. And so that has to be equal to the magnitude of the right force, which also be Coulomb's constant. And you see always the Coulomb constant gets cancelled. So you don't need to know the value of the Coulomb's constant. It is just some theoretical constant. Okay. So in fact, so observe these things that not only the Coulomb's constant get cancelled, but the value of QB also does not matter because that is also going to get cancelled. See, imagine if the charge at B is of double uh, uh, charge, right? Then both forces will be of double magnitude, right? But the net force will be still zero. So therefore, the QB also does not matter. And so if you rearrange this, you are going to get the equation that 4 times QA is equal to QC, right? And now again here, if we should be a little bit more smart at doing this quickly. Like we should, even without writing all this, looking at the diagram itself, you can directly say this 4 times QA is equal to QC. Why is that? Because look at how the distances are, right? See, BA is half the distance of BC, and if still the forces are matching, then it means that the charge at C has to be much more stronger, right? Because as we said, this is an inverse square law. So if the distance is doubling from 10 to 20, then the charge also has to become 4 times stronger. Only then it will be able to balance the attraction of A. Okay, so if you observe that, then you don't even need to write this calculation. Directly looking at the diagram, you can say 4 times Q is equal to QC. Okay, so that is the first part. Now, what is the second part? Now the charge at A is, so now new diagram that now the charge at A is replaced by minus AQ, QA. Okay, and at the charge C is the same, which is QC, or now we know the QC is nothing but 4 times QA. Okay, and now the charge B is moved to point D. So now this point charge is moved to some new location D over here. Okay, and again the question is, the point is the same, that the total charge at D is zero. Okay, so again here if you see now what is the situation, that uh, this is minus minus, so it will repel. So A is going to repel this particle, but C is going to attract the particle, and again the sum is zero, right? So again we are supposed to find the distance of AD, right? So if I call AD as X and this is 30, then I could write the equation, right? So the attraction, the repulsion of A will be so I will not write Coulomb's constant because it will go to get cancelled anyway. So it will be QA into QB upon X square. So this is the force by which A will repel, and that has to be equal to the attraction of C. So that will be QB into 4QA upon this whole 30 plus X whole square. Okay. And now if you see here, everything on the numerator is going to get cancelled pretty much. The QB, QA, QB, QA. And if you rearrange this, you are just going to get a quadratic. 30 plus X square is equal to 4 times X square. Okay. And if you solve this quadratic, you will get two roots, right? So again, this part you should be very proficient with. Like once you get the equation, solving it should not take much time. And immediately when I look at the equation, you should lock your strategy that do I want to use b square minus 4ac, or I can quickly find the roots of this. So here I think that 10 into 30 is a very obvious factorization. So I can quickly write this as, so therefore I'm getting plus 30 or minus 10. Okay. But in this context, the x has to be positive only. The negative x does not make any sense. So the plus 30 is the right answer. So x is 30. Okay. But by the way, can we do we even need to do this calculation? You see another very easy way of just saying that x has to be 30. Do you see why? Because again, now we know the force, the QA is the value of QA, and the value of QC is 4 times that, right? So if the charge is 4 times stronger, right, then the distance has to be a double, right? Like if dA, whatever is the dA, the DC has to be double of that. Only then the attraction of C and repulsion of A will match. So therefore, directly we can say if this AC is 30, then this also has to be 30. So again, if you are efficient at observing these things, you can save this calculation. Directly by the diagram, you can say that this has to be 30. Otherwise, so if the point D is closer than that, then A will have a much stronger influence. And if the point is farther away, then C will have the stronger influence. So, okay, so therefore, the only point where it is balanced is when this is 30-30. Okay. But again, I mean, even if you're not able to spot this, just by applying the Coulomb's that force equation, you can solve this question. Okay. Any doubts? Otherwise, we'll go to the next question. Okay. So the next question, again, very similar setup. I'll just give you 1 minute to think. So what is happening here? Again, there are three charges in straight line, A, B, C. And now this time, if you notice, the they are not given the distances directly, but they are given the ratio, right? So distance between AB is D and distance between BC is K times D. Okay. So this basically this D is going to get cancelled because same as before when we equate the two sides, right? And the denominator will have the square of the distance. So both sides will have D square and D square. So it is going to get cancelled. And now what is in the first situation, we are given plus QA and plus 31 QA. And at B, there is a minus QB. Uh, by the way, just one, sometimes this is called a test charge, okay? Okay. Whenever you have a charge placed here just to test how much is the total force acting over here, then that kind of charge is often called a test charge. That in case you come across this term, you know what it means. It is just some charge particle. Uh, so, so in the first case, the total force at B is minus F1. Oh, sorry, is F1. Okay. So let us set up some convention, that let us say positive to the right and negative to the left. Okay. So that we are able to write things properly. So now at B, A is going to attract and C is also going to attract, right? So the total force acting at B will be given by Coulomb's constant times. So let us first write the attraction by C. So that will be QB into 31 QA upon the distance square. Okay. So this is how much the object is pulled to the right. So that is why it is positive. And then A is going to pull the object to the left. So that will be negative QBQA upon D square. Okay. So if I rearrange this and I will take as many terms common as possible. So I think QA, QB, capital C and D square, all of these are going to come common. And inside the bracket, I'll be left with just 31 upon K square minus 1, right? So this is F1, okay? And then very similarly, they have also calculated F2. So in the F2, they say the charge at A is placed at C and charge at C is placed at A, which means the diagram is interchanged. So now at A, the charge is plus 31 QA. The position of B is the same. And the position of now here there is plus QA. And now again, we have to calculate how much is the attraction and repulsion. So again, F2 will be So the particle will be pulled to the right by this term, and the distances are also the same, right? And it will be pulled to the left by. So you see between the two equations, the top and the bottom, what has changed is just the value of 31. Initially it was in the left component, now it is there in the right component. Okay, so again, all these things will come common, C Q A Q B upon D square, and inside the bracket, I'll be left with 1 by K square minus 31. Okay. And then we are given the magnitude of F2 upon F1. So it is given that F2 upon F1 uh, is 125 by 3. So that will be equal to, so when you take the ratio, all this, whatever is outside the bracket, that is just going to cancel, right? So we don't have to write that also. So what will be left is just 1 upon K square minus 31 upon. So this whole fraction has to be inside this absolute value, right? Okay. So and absolute value means what? The it can be either positive or negative, right? So when I say that some absolute value of some variable x is 5, which means is x is plus 5 or minus 5. Okay, so I have to take both cases into consideration. We don't know which of them is true. So here also we have to, so I think actually there is a mistake in the question, that if you want to do technically this question properly, you have to take both cases. So here I have to have case one, that this fraction is positive. So in other words, case one I have to solve for 125 upon 3 is equal to plus of this fraction. And well, I should simplify the fraction, but I'll do that in 1 minute. And case two is that you take the negative possibility, minus of the same. So the magnitude is the same, but the sign is flipped. So technically either of these can happen. Yes, Harish.
Sir, that it will in case 2 it will not be negative, no, because modulus given.
No, but that is what I'm saying, that if you have some variable, see this whatever variable, I don't know what it is, so I'm calling it x temporarily. So if I say that modulus of x is 125 upon 3, then x can be positive or negative, right? X can be
And
plus 125 upon 3 or x can be minus 125 upon 3,
yes, yes.
right? So ideally, we have to solve both cases and see what is the answer. But so I think this is a mistake. I think maybe the whoever set the paper did not realize that, because one of the cases will give you the correct answer and other will give you some. So k will, because finally the question is saying calculate k. So k has to be an integer, right, of 00 to 99. And so in the one case you get a proper answer, in the second case you get a square, like a improper square root, which cannot be a valid answer. So that is why that we have to discard. But I mean, so just keep that in mind. So let us look at case one. So if I simplify this, 125 upon 3 is equal to, so on the right hand side, let me clear the denominators first. No, so the numerator part, which is 1 upon k square minus 31, that can be written as 1 minus 31 k square upon k square, and whole thing upon, sorry, whole thing upon 31 minus k square upon k square. So if you take the reciprocal of the denominator and put it above, so this will be just 1 minus 31 k square upon 31 minus k square. Okay, so this is equal to 125 upon 3. And so if I rearrange that, like cross multiply, I will get 125 k square is equal to 3 times 1 minus 31 k square. Okay, and now this is just a quadratic equation which will solve as usual. So 25 into 31 minus 3 is equal to 32 k square, right? So therefore k square is, so I need to calculate this product, 125 into 31. So 3872 upon 32 is k square, which I mean, I already done this calculation before, so I think it is 121. So k square is 121, which means k is, so again, k can be positive or negative, like it can be plus 11 or minus 11. But again, because we are supposed to write the answer in 00 to 99, so we can take the positive route. Okay. But so this was case one. As a homework, you can try to do the same thing for case two, and you will see that it is going to give you some fraction, like it is not going to be a proper integer. So we have to ignore that case. Okay, so because of that, this is a slightly lengthy problem. Even this, like, solving this calculation is slightly, it will take few seconds at least. But anyway, at least the theoretical part is relatively simple. It is just we are, if I just zoom back to the start of this question. So the whole theoretical part which was checked was just, can you write these force equations, right? The write both components with the proper sign that understand which, because that is why again sign convention is very important, that if I pick that right is positive and left is negative, then I have to use the same sign convention for both F1 and F2, and basically throughout that given question. Okay, so ignoring the calculation part, I hope that this first theory part is understood well up to this point, that how you calculate the fraction. Okay, so I mean, in this topic of electric charges, this is the only concept. Just that applying that Coulomb's law, that force equation again and again, that is the whole thing. And then realizing some small tricks, that because it is an inverse square law, which means that if the distance is double and the charge is the same, it means the force will be 4 times bigger. Or reversely, if the distance is double and force is the same, then the charge has to be 4 times stronger. So those kind of, mostly common sense principles which will help you to solve some, like save some time actually. Okay. Harish, you have any other doubt, or you need to raise lower your hand?
No, sir, no doubt, no doubt. Sorry, sorry.
Okay, okay, no problem. Okay, so then we'll go to the next question, which is about so this question 16 is interesting. It is actually a combination of two topics. So if you see, read the question, the first part is just this circuit is given and we have to find the equivalent resistance. And then the other part is, some calculation about heating water and how much energy is required or things like that. So this is actually a question which combines the knowledge of equivalent resistance and specific heat. Okay, this is kind of a rare thing that generally in physics questions they don't ask it this way, but sometimes it can come. So for maths, this is more common. So when in the last week when we start to do mathematics, there you will see that combining two topics is very commonly used as a trick to make the question more challenging. Okay, so let us do it part by part. Let us just solve this equivalent circuit and find the resistance. So how do you do that? So I hope that everybody knows the two basic formulae, that series and parallel resistances and how to combine them. So for series resistances, the equivalent resistance is simply the sum of the all the parts, right? So it is R1 plus R2 plus as many resistance are given, just add them together. And for parallel, it is the reciprocal, right? Like that. And so again, some very common sense ideas which you can get from this is that if two resistors are of the same magnitude and they are in series, how much will be the equivalent resistance? If R and R are connected in series, how much will be the equivalent resistance? It will be
2R.
simply 2R, right? Right? And if the same two are connected in parallel, then how much
R
will be
by
the
2.
equivalent resistance? R by 2, right? And yeah, so that this very simple observation will also be useful to save calculation. So for example, in this diagram on the right, uh, how do we start to simplify? Can somebody suggest?
Sir, we start from any one point of the circuit.
Okay,
And we calculate then first last two resistors are in parallel.
Correct.
96.8 and 96.8 मग ते फाइंड केल्यावर मग 48.4
बरोबर.
आणि ते दोन इक्विव्हॅलंट
Correct.
मास हे सिरीज मध्ये आहेत. मग ते दोन ऍडअप करायचे आणि
Correct.
परत मग आलेलं 96.8 पहिलं आहे त्याच्याबरोबर पॅरलल मध्ये असणार. मग ते इक्विव्हॅलंट रेजिस्टन्स काढायचा.
Correct. 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 Okay. So I hope everybody is understanding the strategy that basically you keep simplifying the diagram again and again. Every time take some small part of the circuit and see whether it is in series or parallel, and you keep simplifying. So his first thing what we say is that this last two resistance on the right, they are in parallel. So what do you mean by parallel? They are both connected to the same start and end position. So therefore I can combine them into, so because the magnitude is equal, I can replace them with a single resistance of half the value, right? So if I combine them, I will get a new resistance of half of that, which is 48.4. Okay. And the rest of the circuit remains the same. Okay. So we'll continue with this way. So here we combine them in parallel to get this. Now the next thing we observe is that these two are in series now. So if they are in series, it means I can add them together. So if I add them together, I'm going to get a new resistance of 96.8 from these two. And then finally, one last time, we are seeing that these two are again in parallel. So I can combine them into a single resistance of half the value. So you see how initially we started with a complicated circuit of four resistances, but after this series of operations, we are down to just one single resistance, which is the equivalent resistance of the whole circuit, which is 48.4 ohms. Okay, so this was the first part of the question, just converting the circuit down. Then coming to the second part, that now that I can effectively treat the whole circuit as just a single resistance of this value. Now it is connected to a 220 volt supply. So there is a 220 volt supply to which this is connected. Okay. So then how much is the power generated? Like if I call this R, what is the formula for power? Do we know?
V square by R.
V square by R, right? So in fact, there are two, three different variations depending on which variables are given. So it is I square R, V into I. So depending on what is the information given. So here we know the voltage and we know the resistance. So we use the V square by R. So therefore, the power of this resistance is 220 square upon 48.4. So and see conveniently the denominator is just 22 square after the decimal is shifted. So I can write it as, so I think after everything cancels, I'll be just left with 1000. And the unit of power is watts. Okay, so the resistance has a power of 1000 watts. What does it mean? What do you mean by resistance has power of 1000 watts? Is that resistance is basically this is the amount of energy that it is pulling from the battery or the voltage source. And because energy is conserved, the resistance will simply give off that energy in the environment as a heat, right? So in other words, if this resistance is a heating coil, right, inside your water heater or geyser, then this is the energy which is going to be used to heat up the water. Okay. And that is what we are applying in the second question, second part of the question. So now coming briefly to the topic of specific heat capacity. So uh, we know that if we have, and that is given, that specific heat capacity of water is 1 calorie per gram degree Celsius. What does that mean? That if I have 1 gram of water and I want to increase its temperature by 1 degree Celsius, then how much energy I'm going to require is given by 1 calorie, or which is equivalent to 4.2 joules. So this is the energy required for 1 gram and 1 degree. So we just need to multiply that with the actual quantity, that the temperature is 10 times larger and the quantity is, so 20 liters is 20 kilograms, right?
Yes.
So this is, so you know how much we have to multiply here by 20,000 and here you have to multiply by 10. So the total energy requirement will also get multiplied by the same, right? It will be 20,000 into 10 calories, or in other words, these many joules. So this is the total energy required to whatever they have told that to increase the temperature using that heater. And so if this is the total amount of work to be done, and your resistance is able to do 1000 watts, which means 1000 joules per second. Okay. Now this is just a like a what we have work time speed kind of question, that if in 1 second you are able to deliver 1000 joules of energy, then how many seconds will you require to deliver this much energy? Okay, so then if you just cross multiply and divide, the answer is just going to be this divided by 1000, right? So these many seconds. Okay, and now we can just simplify that. I think we are going to get 840 seconds, which is 14 minutes. So the answer is 14 because they have asked the time required in minutes. Okay, so again, looks like a challenging problem, but really if you break it down, it is just two concepts which you know very well. We are just combining them. So the first concept was equivalent resistance. So you know how to convert the circuit from the original to the this 48.4 joules. Uh, and then knowing that what is the equation of the power, that is V square by R. And the second part is the specific heat capacity, that in knowing the uh, how much energy is required to heat the water uh, through that much temperature increase. Okay, I'll just wait for 1 minute if you want to copy something, else we'll go to the next question. So, I mean, looking at this question, many students often ask that is this exam entrance test difficult or easy? So I would say it depends, right? How you look at it. It is, I don't think it can be called difficult, but it is different. Like you never have these kind of questions in school, right? I don't know, in 10th standard, do you ever seen a question where you have to combine resistance and heat, specific heat together?
No, sir.
No, but I
No,
mean,
sir.
honestly, the topics are related, right? What is power? What is power? Power is just how much energy you are delivering per second. And specific heat is about how much heat is required. How, again, heat is energy. So it is both energy, right? So it can be combined in this way. So yeah, so that is why this is not a difficult uh, exam, but it is an unconventional exam that you have to be prepared for these kind of ideas. Okay, so then let's go to the next question. Yes, Harshvardhan, you have doubts?
Sir, in this question, the specific hits concept is used. So, can you
Mhm.
explain some of the concept of this specific hit?
Yeah, sure. So after two questions, we have one whole, no, two questions on specific hit only. So then we will discuss that in more detail.
Okay, sir.
Yeah. And also, I mean, at the end, because last time also I mentioned is that many students have difficulty in explaining the difference between heat and temperature. So I will also try to explain that properly. Okay, so I think question 16 is relatively easy because here just three circuits are given, and in every case you just have to apply the series parallel concepts, and with that
Sure.
should be sufficient to solve this question, right? So look at the first circuit, for example, we just have three parallel resistances. So I can just write 1 upon Ra, the equivalent is 1 upon 5 plus 1 upon 10 plus 1 upon 15. So that is 11 upon 30. So therefore, Ra is 30 upon 11 ohms. In the same way, I can simplify Rb. So Rb has first this 10 plus 15 can be added together in series to 25. So it is simply 5 and 25 in parallel, right? So 1 upon Rb will be 1 upon 5 plus 1 upon 25. 6 upon 25. So Rb is 25 upon 6. And RC is also, it's just In fact, it is even simpler because this series is 10 plus 5, 15. So 15 and 15 in parallel will be just half of that. So RC will be just half of 15. Okay. So therefore, we found the values of RA, RC. And what are they asking now? Because basically what the question is just trying to do is convert that into a new, integer answer, that these are all fractions. So it is just the rest is some mathematics, that what is the ratio of all these three. Like if I write them as a ratio, 15 upon 2. And then if I want just to clear the denominator so that everything is a natural number. So what is the LCM of the denominator? It is 66, right? So if I just multiply all the terms by 66, I will get uh, oh wait, sorry, I was wondering because last time I did the question, I did not get this. So even before you multiply by 66, right? If you notice the numerators have a common factor of 5. So let us cancel that first, right? I can cancel 5 from all the three because it is a ratio. If I cancel the same term from all the three, it doesn't matter. It will not change the value, right? So it is, yeah. So now if I multiply by 66, the first fraction will become 36 and the next will be 55 and the last one will be 99, right? And so what they are given is LM where LM are natural numbers. So these are the values of LM and N. Okay. And the GCD of element is 1. So you can check that now the GCD of all three of them is 1. So notice that pairwise GCD can still be non-trivial. Like L and N has common factors like 3, but that 3 does not divide M, right? So still we consider GCD of all three of them together as 1 only. Okay. So then just L plus M plus N upon 2 is 195, right? So that is the answer of this question. Okay. So I hope that this was relatively straightforward question, I would say. Again, so these are the questions which should be time savers for you, that you should spend less than the average time required on this question so that you can apply it for more harder questions. Okay, so these were all the questions on electric equivalent resistance. So again, it is just those two things, the series and parallel formulae. Applying them, you should be able to solve any questions of this type. So then coming to the next topic of specific heat. Uh, so yeah, let me explain that in more detail. So theoretically, what we have to understand simply is that heat is also a kind of energy, right? So all questions of this type are based on two concepts. One is that, energy conservation, that total energy of a system remains constant. So you cannot create or destroy energy, which means that you cannot create or destroy heat also so you see all these questions always have this word insulated container. Like if you see here, insulated container. What is the meaning of insulated container? You can imagine it as a box through which you're not allowing any heat to enter or escape the system. Like imagine your thermos water, like when you put hot water inside a thermos, that water remains hot for a long time because the thermos is designed in such a way that it traps the heat inside. So it does not allow heat to escape or enter. Of course, it is not a perfect insulation. Slowly the water will lose some heat, but in ideal situation, what we consider is a perfect isolation. So, so inside such a container, the total heat will remain the same, which means we can say that the heat uh, lost by one substance has to be equal to the heat gained or absorbed by another substance. Okay, so imagine that if you have two objects here and one of them is losing heat, then the same amount of heat will be absorbed by the other object. There is nowhere else for the heat to go. Okay, so this is the most important concept which is useful in these kind of questions. Okay, just equating the heat lost and heat gain. And then the second part is how much heat is lost. That how do you quantify that? How much heat is given by an object, and that is where it is related to the temperature. So each substance has this concept of specific heat. Okay, so specific heat is you can say it is the unit of how much heat is absorbed or emitted by the object. So typically it is given in units of uh, like for 1 gram of the substance, and if I want to change its temperature by 1 degree Celsius, then how much heat is required? Okay. So typically for water, for example, it is well known that water has the specific heat capacity of 1 calorie. So 1 calorie per gram degree Celsius. Okay. So that is what exactly we used in the previous question, right? If I have 1 gram of water and I want to heat it through 1 degrees, I will need to, supply it with 1 calorie of energy. Okay. Or 1 calories can be converted into joules if required. But either they are both units of energy, it doesn't matter. And then if 1 gram requires this much energy, obviously if you have more water, you will require more heat, right? So this is just like unitary method that if I have m grams of water instead of 1 gram, my heat requirement also be multiplied by m. And if the temperature is also instead of 1 degree, I need to raise the temperature by T degrees, right? Then again, I will require more energy. So therefore, the total heat requirement turns out to be, so the specific heat of capacity of that object multiplied by the mass, like how much of the mass you are taking of the substance, and how much is the change in the temperature, which is typically written as delta T. So the product of all these three will give you the heat energy required for that object. And then for different substances, the value of C will be different. So for water, it is 1 calorie per gram. For metals, it is typically much lower. Okay, so metals, like even in your kitchen, you can do this experiment. That if you have on the gas stove, if you place a metal pan and you start the gas, immediately the metal heats up. Right, if you touch the metal surface of the pan, you'll immediately see that it is hot. But instead, in that metal pan, now if you pour water and now you see the water will not immediately heat up. It will take some time for the water to warm up to the same temperature. That is because actually water is one of the highest specific heat capacities of all the substances available. That, maximum energy is required to heat up water, and same to cool down also, right? So once the water is heated up, it will remain hot for a long time, and it will take a lot of effort to take away that heat from the water also. So even cooling down water, will emit a lot of heat. Versus that, something like metal will absorb heat quickly and it will release heat quickly also. So these are, various ways in which substances behave. Okay. And then apart from the specific heat, there is also the topic of latent heat. So latent heat is involved when there is a change of state. So when substance goes from solid to liquid or liquid to gas, you know how water behaves, right? That so you must have learned this in school already. So I'll not repeat it in a lot of detail, but basically, when the let us say ice is melting to become water, it does not immediately change the state. It has to first completely melt. It has to absorb enough energy to become from ice to water, and only after that it will start increasing temperature. And same for going from water to steam. So that is what is called latent heat. Okay. So this is just a quick overview of the important concept. If something is still not clear, I will say that, talk to somebody else, or check something online. Yes, Harish, you have any question?
Sir, please explain difference between specific heat and latent heat.
So, okay, so specific heat is about when there is no change of state. So when a liquid remains a liquid, but still you have to give it some heat, right? To heat that object or heat that liquid. So that is specific heat. And latent heat is the heat required when the temperature is not changing. So, if you have 100 grams of ice at 0 degrees Celsius, And if I start to warm it up, after a while, it will become 100 grams of water, but it will be still at 0 degrees Celsius. So there is no change in the temperature. So if there is no change in temperature, I cannot use this formula because then delta T is 0. But in this process, the ice is still absorbing some heat. So that heat is required, like on the molecular level, what is that heat required for? It is to break the bonds, right? So the ice molecules of ice are arranged in a crystal structure, and from that crystal structure, it has to go into water where all the particles are separate. So to break that bond, some heat is required, some energy is required, and that is what we call the latent heat. So when latent heat is being applied, the temperature does not change, but the object changes from one state to another state. So it goes from ice to water, or it will go from water to steam, for example.
Yes, sir.
Okay, so I mean, I think when we start to solve the questions, it might you understand how to apply this exactly. Okay, so question 17, what is given? So as I said at the start, that often all of these questions are done with the insulated container. So, and we can draw the diagram, something like this. So, initially, what is the situation that you have a metal of, so you have a metal of mass of, I don't need to draw the metal. I'm just going to write metal of mass to 205 gram. And I know temperature of the metal is 1100 degrees Celsius. And in the same container, I also have ice at 0 degrees Celsius. And how much? 1000 gram of ice at 0 degrees Celsius. Okay. So what is going to happen that the metal is hot, the ice is cold. So the metal is going to start cooling down and the heat will transfer from the metal to the ice. And remember the principle that heat lost by metal is all the heat absorbed by the ice. And after some time, equilibrium is reached. So after some time, what will happen? The whole system will come to some common temperature, T. Okay. And what is the question saying? Calculate the mass of the steam present. So which means, see, the question is giving you some possibility. See, in reality, so many things can happen, right? One thing is that the metal will cool down completely to 0 degrees and the ice will remain ice. Like some of it will become water, but it will not completely melt. That can also happen. Or in one situation, the ice becomes water, the water becomes steam, all the water becomes steam. So then the container has only metal and steam. But so there are so many different possibilities that can happen. But for our convenience, the question is already giving us some information that calculate the mass of the steam present. So which means when the equilibrium is reached, what is going to happen is the metal has also cooled down to temperature T. Uh, the water uh, has like water was raised up to 100 degrees Celsius. Okay, so which means the equilibrium temperature was 100 degrees Celsius. It is not an unknown variable. So what will happen? All the ice became water. It boiled to 100 degrees. And after that, some of it became steam, not all of it. Okay. So some of it has become steam, but some of it is still water. Okay. And we don't know how much of it is steam, how much of is water, we don't know. That is what we have to exactly find out here. So let us say that X grams of steam was produced. Then the remaining 1000 minus X is still water. Okay. And so therefore, initially we have 1000 grams of ice, and finally that ice has converted into some water and some steam. And now we have to calculate in this whole transaction how much energy was lost by the metal, and that will be equal to the energy that is absorbed by the ice. So let us write that. So energy or heat lost by the metal will be equal to, so if you use the specific heat capacity, the formula, so specific heat of the metal is 0.1 gram calorie multiplied by the quantity of the metal and into the temperature change. So how much is the temperature change? It went from 1100 to 100 degrees, right? So it has lost 1000 degrees of temperature. So this is the heat that the metal has given. And now that has to be equal to the heat absorbed by the ice. Okay, so or ice slash water slash steam, whatever that combination is there, right? So now how do we calculate that? First, let us see how much energy it required for the ice to become fully water. So the first step was 0 degrees Celsius of ice become fully into 0 degrees Celsius of water. So this is where the temperature is not changing, only the state is changing. So we have to apply the latent heat formula. So what is the latent heat of? So if you see here, there are two latent heats given: latent heat of fusion and latent heat of vaporization. So what are those? So when an object goes from solid to liquid or liquid to solid, this is when the latent heat of fusion is considered. And between liquid and gas, it is the latent heat of vaporization. Okay. So the two equations have two different rates of conversion. That so for fusion, for example, it is given as 80 calories per gram, which means to convert 1 gram of ice to water. So 1 gram of ice into 1 gram of water requires 80 calories, right? And so then in our case, we have 1000 grams of ice, right? So if 1000 grams of ice is given, how much can energy will be required? It will be simply 80 into 1000 calories. Okay, so this was the energy required to convert all the given ice into water. Okay, so this is the first component. Then the second component is now that all the water has to go from 0 degrees to 100 degrees, right? So now this is where specific heat is going to be applied. So that is simply how much specific heat is required to make this conversion. That will be the specific heat capacity of water, which is 1 into the quantity of the water, which is all 1000 gram into the temperature change, which is 100 degrees. Okay. So the first component was the latent heat for going from ice to water. The second component is the specific heat, the total heat required to go from 0 to 100 degrees. And then finally, out of that 1000 grams of water, as we said, some of it is going to become steam, right? So we have said, let us say X grams is going to become steam. So we are going to require only that much energy to convert X grams of water into steam. And so that will be equal to how much? The latent heat of vaporization is given as 540 calories per gram. So this will be 540 into X, right? And so the total amount of heat absorbed is the sum of these three components. And that has to be equal to whatever energy was lost by the metal. So therefore, now we can write our equation as, so let me just temporarily expand this. So if I scroll up, so the heat lost by the metal was this much. So therefore, my equation will be this is equal to the sum of all of this. So 80,000 plus 100,000 plus 540x. And so in this, I just had to find the value of x now. So okay, so I'm going to get I think 9 will get cancelled. Oh, yeah, okay, 9. So, I think I'm going to get the answer as x is 75. Is that correct?
Yes, sir.
Yeah, okay. Okay, so the calculation was really straightforward. But to find the equation, we have to do all of this. And the conversion of ice to water and water to steam was a bit more complicated. So just make sure you understand that process properly. That first we are converting all the ice into water, applying latent heat. Then we are converting the water from 0 degree to 100 degrees using this part. And then you are converting only some part of the water into steam, which give us this last part. And then we added all three together. Okay, so I hope this clarifies the difference between where. So in this process, we are applying specific the latent heat here and here in the first and the last part, and specific heat here. Okay. Then going to the next question. Again, that will give one more chance to apply this concept, to make sure that you are understanding it properly. And the setup is again very similar, that you have an isolated insulated container in which some objects are given, some mass and some, let us see what all is given. And so this diagram is often very helpful, that you write the initial situation, and just like how thermometer has temperatures from bottom to top increasing, so you write it in that way. So here, if I have to show that the metal as at is the highest temperature, right, 660 degrees. So that is why I write the metal at the top of 660 degrees. Okay, maybe let's write the mass first. 100 grams of metal at 660 degrees Celsius. And we also have in the same container steam of 100 grams at 100 degrees Celsius, and 500 grams of ice at 0 degrees Celsius. Okay, so this is what you have initially. Okay. And after some time, equilibrium is reached. So equilibrium means all the substances will come to some common temperature T, which we don't know. Okay. So again, theoretically, many things are possible here, right? Imagine that you have so much ice that instead of 500 grams, you imagine you have 5,000 or 50,000 grams of ice. Then the ice will be only so cold that it will bring the whole system down to 0 degrees. That is also possible. Or in the other case, you could have so much metal at very high temperature, which will cause everything to boil and become come to the temperature of the metal. So both are possible, but again, we have to use the knowledge that the answer is going to be between 00 and 99, right? That is what we know. So let us use that to our advantage. And so that means that what is most likely going to happen is that the uh, ice, both the ice and the steam will become water. Okay. So the ice will convert into water and increase temperature, and the steam will cool down and also become water. And then the metal will also come to the same temperature. So the final container will have metal and water at T degrees Celsius. Okay. So again, same equations, the heat lost and heat gained. So let us first write the heat lost by the metal, because that is more straightforward. So that will be simply the specific heat of the metal 0.2 into how much of the substance, 100 grams, into how much temperature was. So temperature went from 660 to T, right? So I just write that delta T as 660 minus T. Okay. So this was the heat lost by the metals. Uh, then even similarly, steam will also lose the heat. So heat lost by steam. So how much will that be equal to? So that will have two parts. One is the heat required, the latent heat to convert the steam into water. So again, that will be 540. It is given the heat of water, latent heat is 540 calories per gram. So it will be 540 into the quantity, which is 100 grams. So this is the heat required to convert the steam into water. Plus, then I have to consider that that 100 degrees water will cool down to T degrees. So that will also lose additional heat of 100. Again, it is 1 into 100. 1 because specific heat capacity of water is 1 into 100 minus T. So this is the total heat lost by the steam. And then what is the heat that is gained or absorbed by the ice? So ice starts at 0 degrees. So first that all the 500 grams of ice has to become water. So that will require 500 into 80, this many calories. and then the 500 grams has to heat up to T degrees. Okay. So these two are losing heat and this is gaining heat. And so the sum total has to be matched. So therefore, the heat gained by ice, this has to be equal to the sum of the previous two. So the equation I'm going to get is 40,000 plus 500 T. So this is the heat gained by the ice is equal to the sum of the first two components. So 54000 plus 100. And now you see this is just an equation when capital T is the only unknown variable. So if I solve for that, I will get the answer. So this is simply 20. So therefore I want to get 620 T is equal to I hope I'm doing the calculations correctly. If you spot any mistake, let me know. Okay, I think this is simply 6 times, right? So I think should be 60. Oh no, wait. Mm, yeah, yes, correct. Okay, so therefore the answer is 60 degrees Celsius. You confirm that is correct. Okay, so again, applying the same concept again and again that uh, everything comes to equilibrium at T degrees. So metal has to lose this much heat. The steam has to first convert it to water and then cool down to T degrees. And the ice has to first absorb the heat to become water and then heat up to T degrees. And then you just equate the heat lost and the heat gain. Okay, so I hope these two questions give you the clarity of how to apply this concept. Uh,
Yes, sir.
Apart from that, there is nothing more to this topic as such. And very rarely you will have the question of what we did earlier, where you have to combine the idea of specific heat with the resistance formula. But again, that is not very difficult once you understand that resistance is just going to give off the power as heat energy. Okay, then coming to the next question. So now I think we are done with all other topics. Now it is just optics that is left to be done. Uh, and I think we have, yeah. So typically we will have one or two questions on the idea of lenses, the convex lens, concave lens, and the focal length, that formula, and some on mirrors and shadows and things like that. So yeah. Okay, so this first, generally when you have questions on mirrors and things like that, they are not really physics questions. If you ask me, that is more like a geometry question. Like if you just look at this question 15, I'll give you 1 minute to think about this, but mostly it is just finding some angles and things like that. Yes, Prasanna, you want me to talk about Amra and Penumbra? We'll do that for the next question. Yes, Harish.
Sir, is the answer for question number 15 is 45?
Is it 45? Yes, it is 45, correct.
Yes, sir.
So you see, right? It is mostly geometry question only. It is not. I mean, the only thing, the only property of mirror that we know is angle of incidence equal to angle of reflection. If you apply that again and again, you can do questions like this. Okay, so let me draw the diagram roughly. Okay, so what is given is that we have this ray of light which is bouncing across multiple mirrors, like what they have shown. And finally, what they are saying is at the end, the final ray is parallel to the initial ray. Okay. Okay, and we are given some angles. So by the way, even before we do this problem, just to clarify our concept about parallel lines. So when you have two parallel lines, right, and you have a transversal, I hope everybody knows the properties, like which angles are equal, which are supplementary. All those things must be done in school, right? For example, this what are called corresponding angles are equal, and these are supplementary angles. What is the name given to this? Opposite. What? I forgot. Sorry. What is the name given to this cross and dot when they are like this? Alternating angles or forgot.
Linear
Anyway,
pair of
doesn't
angles.
matter.
Linear pair of
Pair.
angles.
Okay, fine. Yeah, yeah, whatever you want to say. Yeah, but basically the all the dots are equal and the dot plus cross is 180 degrees. So all this is can be applied when you have two parallel lines and their transversal is given. In this question, what is happening? AB and DE are parallel, right? What the question says is that line AB and line DE are parallel to each other. But there is no transversal like this, where if the same line cuts both the segments, only then these concepts can be applied. So if no such line is there, then how will you solve this question? So there is one more trick, which is we can introduce another parallel line to the same family. So what I will do is to parallel to AB and D, I will draw one more line passing through C like this. Okay. So this third line, which is parallel to both of them. Okay. And now what will happen at the vertex B, C, and D? Now you have these two multiple transversals, right? Here you have this segment BC is one transversal for the first pair, and CD is the transversal for the second pair. And so now separately I can apply the properties and get what I want. Okay, so this trick of introducing a third parallel line, this can be useful many times. Okay, and apart from that, now what all other information is given to me? So this angle is 20 degrees. Okay, and now knowing that angle of incidence is equal to angle of reflection. So if this is 20, then the angle over here is also going to be 20 degrees. Now this is 25, then this is going to be 25, and then this we have to find out. So if let me call this unknown, this angle as x, okay, but the same value will be on this side also. This will also be x, okay. So now let us see what all angles I can find in this diagram. So let us start from the initial point. Like at point B, I know this is 20, this is 20. So can I find the angle in between? That will be simply because sum total of all angles has to be 180 degrees, right? So this angle in between simply be 180 minus 20 minus 20, right? In other words, that is 140 degrees, correct? No, not Celsius. This is not temperature. By mistake, I read 140 degrees Celsius. Okay, so this is 140 degrees, this angle. Then from this angle and now this trick of parallel line. So now how much will this angle be equal to? Which is the supplement of this angle. So this will be 180 minus 40, 140, which is 40 degrees, right? So this is just this part to the left of the green line. But now therefore at this point I can find the remaining angle also now, because the sum total here is 25 plus 25 plus 40, which is 90. So in my diagram it doesn't appear it that way, but this is supposed to be 90 degrees. And then if this is 90 degrees, then how much is this going to be? Again, this is also going to be 90 degrees because again, this has to be another supplementary pair. And then if this is 90, then 90 plus x has to be 180, and therefore x is 45. Okay, so you just repeatedly applying two things. That one is that if I have a point where you have multiple angles like this, then the sum of all of these angles will be 180 degrees. And if I have parallel lines, then this and this are supplementary. So we just use this again and again at all the points. So I hope I went a bit fast, but I hope everything was clear. If not, I can repeat.
Clear, sir.
Okay. Yeah. Okay. So yeah, again, as I said, that not really much of a physics question, more of a geometry question. You can, in fact, derive a much more general formula of this kind. Okay, I will encourage you to do this as a homework, So here the values were given 20, 25, but let us do the same problem in terms of, variables. Okay, and try to see if you can find some general formula. Okay, so in fact, so this is your homework. Again, this is maybe not everybody may be interested to do this, but I'll encourage it highly that, try this problem. So let us say simple case of two mirrors. Okay, so two mirrors. Suppose there are two mirrors, and always the situation is this, that I send one ray of light, and after it bounces, the ray of light that I get back is parallel to my original ray. Okay. So if this happens, and if the angles of incidence are AA and BB, then find the relation between A and B. Okay. And then keep on doing this for more and more mirrors. So suppose instead of two mirrors, I have three mirrors. Like in this question, I had three mirrors, right? And again, the same thing, that I send a ray of light. It first bounces with the angle of A, second bounce of angle of B, and third bounce of angle of C. And again, the returning ray is parallel to my original ray. Then find the relation between A, B, and C. And so like that, you can keep on doing for three mirrors, four mirrors, and see what is the pattern that you're observing. Okay. And if my intuition is correct, you will see that always the angles add up to 90 degrees. So here, in the case of two mirrors, you'll see that A plus B is 90. In the case of three mirrors, A plus B plus C is 90. In the case of four mirrors, it will be like A plus B plus C plus D is 90. So this will keep happening. Yes, Harish?
Sir, earlier I have solved this question from that Yam Prakash question answers.
Okay.
They are given that incident angle of the mirror is theta.
Okay.
Then deviate from its original direction by 2 theta. Why it is given as 2 theta?
All right. Yes, that is a correct way of looking at it. So basically, what they are saying is that imagine this situation, right? That there is a ray which is coming like this. Okay, and after reflection, it goes in this direction. Okay, and if this angle is theta, then we know by our school physics that this angle of incidence and angle of reflection is equal. Both they're both theta, right? Now think of it this way: like this ray was traveling in this direction, right? If the mirror were not there, like it will just continue traveling like this without any change of direction. But because of the mirror, the path of that light changed. So how much was the change in its path from this direction to this direction? The total change of angle was this much, right? And so how much is the value of this angle? It is 2 theta, right? Because this is theta, this is theta. So then this whole angle is 2 times theta. So the mirror caused the path of the light to deviate by 2 theta.
Yes, sir. Thank
Okay.
you, sir.
And so that is a very useful idea. So if you have one more mirror, that will also cause the additional deviation, and you can add up all those parts. I think that is yeah, that is one way which you can use to prove this, what I'm asking. That is A plus B plus C is 90. All of that can be proved with this concept.
Yes, sir.
Okay, so that was question 15. Uh, okay, then the question 15 of the other paper. So this is where the shadow concept is being applied. And okay, so maybe before talking about this question, because somebody had asked this doubt that what is umbra and penumbra. Uh, so in general, when you have a light source, right? Yes, okay, else was asking, and everybody is posting a different spelling of umbra and penumbra. And at least the spelling which I know is umbra and penumbra. So the idea is very simple. Umbra is all the region that is completely dark. Okay, where no light reaches, that is called umbra. Okay, so which means that part is completely in a shadow. Penumbra is the part which is partially dark, which means maybe some light is reaching there, but some shadow is also there. And then finally, there is no, I don't know, there is a term for this, but something that is completely in light, completely illuminated, let us say. So, the screen can be divided into these three parts. Okay, let us take an example that let us say there is a uh, so when there is a light source which is like a what is called a point light source. Okay, point light source which means that there is a single point which is emitting light. In real life, this never happens, right? Even if there's a light bulb, that light bulb has some size, right? Some magnitude, like some width, breadth, height is there. So the point light source is an ideal situation, which never really happens in real life. But for the moment, let us say there's a point light source and there is some object over here. Okay, let us say there is a circular disc and there is a screen over here. Okay. So then from that point, I can trace the rays of light which are traveling in a straight line and they hit my screen. And so this circular disc will cast a circular shadow like this. Okay. And now you can see that because light cannot bend, right? So light cannot, no, this is not possible. Light cannot jump like this, which means that this part is completely dark, right? So therefore, this is called the umbra. And in this case, there is no penumbra because every point on the screen is either completely dark or if it is here, then it will be directly the light will reach there. So there is no shadow. So if the light source is a point light, then there is only umbra. There is no penumbra. But in a real life, what will happen is that instead of a point like this, let us say the light source also has some dimension. Let us say it is a circular ring. Okay. And now your object is same as before and your screen is here. Now what is going to happen? There are two things going to happen. Uh, if I take the top of my light source and the top of my object and I trace it like this, it will reach the screen somewhere over here. And if I take the bottom of my light source and bottom of the object and trace it, it will reach somewhere over here. Okay. And like that, I'll get a ring of shadow over here. And once more, you'll observe that everything which is in this part is completely dark because there is no, you can try this, that every point on this light source to reach this, it has to pass through my object, which is not allowed because the object is completely opaque. So therefore, this is the umbra. Okay, this is the completely dark shadow. Okay, but apart from the umbra, if you notice the region around it, right? So consider a point somewhere over here, okay? And try to see from here how much of the light source can I see. So what you'll observe is that if I trace the rays back, you'll see that only some part of the light source is visible from here. The entire light source is not visible. Like if I were to take the top of my object and throw this ray, sorry, my diagram is not very accurate, but basically this path is not possible because again it is passing through my object. So therefore, from this point, only some part of my original light source is visible. So this part will not be completely dark also and completely light also. So that is what we call the penumbra. Okay. So it will be partially illuminated. And this will happen for some distance. After a point, once you go very far, then from here again the full light source is visible. So this part is completely illuminated. So therefore the screen is divided into these three parts, the umbra, the penumbra, and then the rest of the screen which is fully illuminated. Okay. Yes, Harish.
Sir, what is then anti-umbra?
Anti-umbra. What is
Yes.
anti-umbra? I never heard of this term.
ANTUMBRA.
Let me Google it. I have never heard of
Antumbra.
this term. Antumbra. Okay, I never heard of this antumbra actually. Let me read it.
It might be the completely
Um,
illuminated area. They might
this
be
is the
calling for.
reason the occluding body entirely appears within the disk of the light source. I reading this, I'm not able to understand what they are saying. But I don't think you require that concept. So maybe we have to go on YouTube and find some lecture which explains this properly. But for our requirement, this is not really required.
Yes, sir.
Yeah. Okay. Prasanna, you have any doubts?
Yes, sir. We can draw a penumbra from that top of the light source also.
Uh, yes, we can draw the penumbra. So actually, my diagram is not very accurate. No, that is why this is hard to follow. Uh, Let me draw a more accurate diagram. Maybe. Okay, so imagine that this bottom surface is the screen, and I'm going to cast the shadow from the top. And so let us say that I have um, sorry, I'm not able to use this. Okay, this 3D view is difficult for me to figure out. Let me go back to 2D view. Okay, so we are looking at the side view. Okay, so let us say this is my screen. Okay, this is my object which is going to cast the shadow, and this is my light source. Okay, and I'm just drawing them roughly parallel, but they're not exactly parallel. Okay, and now let us trace the lines. Okay, so from the top of my uh, light to the from the top of my object to the screen. So this is where the umbra will start, and similarly the bottom of my light source and the bottom of my object. So this part GH is the umbra. Okay. In the same way, if I start from the top of my light source and the bottom of my object, so this light ray, wherever it intersects my screen, this point I is the sort of the last point of my umbra. Because if you see from point I, the light source is just barely visible, right? If I go from I, this light ray ID, if I trace it back, it reaches the top of my original light source. So anywhere from below I downwards, again everything will be visible. So therefore my penumbra ends over here. And similarly from F to C, so this is my, so you see I have to basically, because this is a side view, it is looking like two parts, but basically this GH is my umbra, and uh, the two segments at the top, this GJ and HI, these are the penumbra. Okay, and everything outside of that is fully illuminated. Yes, Prasanna?
Yes, sir.
Yeah, okay, is this clear? And so by the way, this GeoGebra is very nice. So if you see here, like if I move my light source, you see how the umbra and penumbra are changing. And the point which I said, that suppose the light source is a point light. Imagine that this E and F are coincident. You see that the penumbra disappears, that you only have umbra. There is no penumbra. But if your light source become larger and larger, then your umbra becomes small and penumbra becomes large. And in fact, it is possible that this umbra also completely vanishes. That imagine that your light source is only so big, no, like this. That now there is no point on the screen which is completely occluded. From every point on the screen, some part of the light source is visible, like a tube light. Like a tube light is a typically a very long light source, so it will not cause any penumbra at all. But if your light source is of a smaller size, then you'll get a umbra. Sorry. So like that, multiple cases are possible. You can play with this. You can draw these diagrams on paper also to see what happens in different situations. Okay. So going back to the questions. Okay. So let us see what is happening in this question. Again, so this is really just a geometry question, not much apart from that to be applied. Okay, so in this, let us see what will the dimensions of the umbra and penumbra are going to be. So the wall is here. Sorry, I'm trying to draw accurate diagram. It is okay. So this is the object, and as I said, that the light source has to be of some dimension. And the question says the object is exactly midway between the wall and the light. So this is important. Okay, so the fact that the distances between these two are equal, we are going to use that in the calculations. Okay. And now, so let us say, let us trace the light sources, right? For the umbra, if I join this line, so because the object and the light are both circles, so the shadows are also going to be circles. So this is the diameter of my umbra. Like this distance is the diameter of my umbra, and then what about the penumbra? So penumbra will be traced like this. I start from the top of my light source, and if I join the bottom of my object, and then if I do it the same way on the other direction, so this is my uh, diameter of the penumbra. So what they have said, this is the dp and this is the du, okay? The diameter of the umbra and penumbra respectively, and we have to find the ratio of this dp upon du. Okay. uh, And by the way, one more thing which is given in the diagram, which did not write in the question, is that the light source and these are also related. So these are given as d and 2d, right? So this distance is d and this distance is 2d. Okay. So, uh, so again, as I said, this is mostly just a geometry question. Let me label the points. Okay. So let me call this point as xy. So xy is my light source. AB is my object, and these points are some, I don't know, I, J, K, L. Okay. Now I want you to focus on triangle. So ignore X for the moment. Just focus on triangle Y, I, K. Just look at triangle Y, I, K closely. If you want, let us draw the triangle Y, I, K separately so that understand what is happening for this triangle. So this is triangle Y, I, K. And in that, if you notice, B is the midpoint of YK, right? And why is it a midpoint? Because all these distances are equal. So basically, YB and BK are going to be equal. And similarly, A is the midpoint of YI. So does this remind you of any property which you have studied in school? A and B are both midpoints in this triangle. So what is going to happen?
Midpoint theorem.
Midpoint theorem, right? So because of midpoint theorem, what I can say is that this segment AB is parallel and half of the base IK, right? So if this AB is of distance 2D, then this base IK will be of length 4D. Correct? I hope everybody is following this. So therefore, in my original diagram, let me mark this IK as 4D. And same thing, this I did from Y. Same thing I can do from X also. Like if you look from X, XAJ, A is the midpoint, and XBL, B is the midpoint. So therefore, this AB will also be equal to half and a half of the length of JL. So therefore, this JL is also of length 4D. And then finally, there is also some congruent triangles in the diagram because if you look at this, see this through point A, YAI and XAJ, they are like they are forming a parallelogram, right? If you see that this is a parallelogram, IJ and YXY will be equal and parallel because these two triangles are congruent to each other. I mean, you can also see it in this way that XJ and YA both have XJ and YI have the same midpoint A. And one of the properties of parallelogram is the diagonals bisect each other. So that is why XYJI is a parallelogram. And if it is a parallelogram, then this length is D, which means that this length is also D. IJ is also D. And in the same way, KL is also D. Okay. So this on this line IJKL, many things are happening. So let us draw it separately just to clarify. Okay. So if I draw this IJKL over here, and from where we are getting all these properties. So the question is, by the way, we have given that JK, we are going to call as DU, which is the diameter of the umbra, and IK is my DP, the diameter of the penumbra. So I'm interested in calculating these two lengths, JK and IL. Okay, but what we have found so far is IK is 4D. Okay, so this distance is 4 times D. Again, why is that? Because of the midpoint theorem. And just now we said that Ij is D. Okay. Again, I hope it is clear why Ij is D because these two triangles are congruent. So therefore, Ij is D. So if Ij is D and Ik is 4D, so this part in between has to be 3D. So which means the du is 3D, 3 times D. And then finally, the last part is also D. So the total length of dp is D plus 3D plus D, which is 5D. And so therefore we can find the answer 9 into dp upon du is 9 into 5D upon 3D, which is 15. Okay. I will highly encourage you to, because here the numbers were very specific, right? This D, 2D was given, this distances are equal. All of these are special cases, but you can easily solve this question for the general case that if assume some variables for all these things that imagine that the light source is of length L, the object is of length O, and like that, put variables everywhere and solve the question. Then you will get the general formula. Yes, Harish.
Sir, how the value of DP came 5D?
DP is 5D because what is DP? DP is the sum of these three segments, right? IJ, JK, and KL. And this is D. This is the part in between was 3D. And this is also D.
Yes, sir.
Yes, Prasanna?
Sir, can you again explain that how we got to know that length of that three segments?
Yeah, okay, sure. So, in fact, again, let me draw the diagram accurately. Maybe that will help. Okay, so let us say that this vertical line is our screen, and let me draw. Okay, so this is my let me use the same notation. So AB is my object of length, whatever length is given, and at the same distance, this is my light source. Okay, so XY is my light source, and so this object is of twice the size of the light source, and then through X and Y, I will draw the lines to form the umbra and penumbra. So this is the umbra, and this is the penumbra, and so these points we label them as I avoided the label CDEF because the D was there in the question also, right? That it would be confusing which D we are referring to. Okay, so these are my IJKL. Okay, so first thing, do you observe here that we have these two triangles which are congruent? X A, this triangle AXY and AJI. These are congruent. Do you see that? Because you can do it in two different ways. One is that just A is the midpoint of both these segments, right? XJ and YI. So by SAS test, you can say that they are congruent. And so if they are congruent, then this XY, if this length was given as D, XY is D, then IJ is also D, right? And the same thing I can do for the bottom pair, that triangle BXY and BKL are also congruent. Therefore, this KL is also D. Okay. So you could find the two segments on the side in this way. And for the middle part, our observation is that focus on this triangle, triangle YIK. Okay, in this triangle YIK, because A and B are midpoints. So by midpoint theorem, AB will be half of IK. So if AB is half of IK, which means that whole of IK is 4D. And therefore, if I subtract the IJ part, then what is left in between is 3D. So therefore, JK is 3D and the two on the top and bottom are D. And therefore, the total length becomes 5D.
Okay, sir.
Okay, is that clear?
Yes, sir.
Yeah, okay. If you want, you can take a screenshot of this. Okay, so yeah, let us go back to the questions. Okay. So, but again, if you again, what I want to emphasize is that this question and the previous question, it is just geometry. So, if your mathematics is good, your geometry is good, you should be able to do these questions without much difficulty. Okay, then coming to the remaining two questions, which are on the convex lens, like the lens equation. So, actually, in the last batch, I had to spend a lot of time to clarify some confusion because uh, what I am going to recommend is something different from what is done in school. So please pay close attention to this. So the lens equation, right? As you know, this is the equation that gives us the relation between the object, the distance of the object and the image from the lens, right? So typically, if you have some lens like this, the convex lens, and the object is going to cast an image like this. Then typically we use small u and small v for the distances from the lens, and f for the focal length of the lens. And so even before I write the lens equation, right, the values of u and v and f, all of them, sometimes you have to take them positive, sometimes you have to take them negative. And so we use what is called a sign convention, right? That how we decide whether to take it positive or negative. And the important thing is that there is no fixed rule which everybody has to follow. There are different systems. Just as what we did before, like I was taking the system always as, upwards is positive, downwards is negative for gravity. But somebody could do it reverse. Somebody could take this positive, this negative. That doesn't mean you're wrong. There's just two different ways to solve the question. So in the same way, there are multiple sign conventions possible. And what you study in school is called coordinate sign convention, typically. Okay. And I'll not go into explaining what that is because you must have learned it in school already. But I'm going to ignore that completely. And I'm going to teach you a new sign convention, which I don't know the name, but somewhere I've seen it is called a Gaussian sign convention. Okay, and we are going to learn this sign convention, which is different from what you learn at school. And there is a reason why this sign convention is preferred, and you are going to use this in your JEE studies also. That is why I'm introducing this to you. In your 11th and 12th standard, you are going to use Gaussian sign convention, not the Cartesian or coordinate sign convention that you learned at school. So don't get confused that why is the sign different. And because the convention is different, the formula are also different. And all of this is given on online. If you just go to thin lens equation. So this if you see this table which is given on the Wikipedia page, this explains this in not complete detail that when you take which positive, which negative, and things like that. So I'm not inventing some new system. This is what everybody uses. Okay, and I don't know why they don't teach this in school. I don't know, but here also, if you see here below, they are saying that there are other sign conventions such as Cartesian sign convention, but for the reasons which I will explain, the Gaussian sign convention has some advantages. Okay, so what is the Gaussian sign convention? Uh, Actually, it is very simple. It says if the object is real, object or images are real, then take the u or v to be positive. If they are imaginary, then take it to be negative. Yes, Harish?
Sir, if you take different sign convention by different person, then the answer will be different, no?
No, it will not be different. The answer will be the same. So if you want, you can do the same question in two different conventions, and at the end, you will tally the answer is the same.
Yes.
Okay. Okay, so the sign convention we are following is that real objects, you take the u and v positive. Imaginary object, you take it to be negative. And for the lens, convex lens, you take positive, and concave lens, I mean the focal length. Okay, the focal length is for convex lens, it is positive. For concave lens, the focal length is negative. Okay, so very simple sign convention actually. I feel this is very easy to explain. And the what I like the most about this sign convention is, what the lens equation becomes? It becomes 1 upon u plus 1 upon v is equal to 1 upon f. Okay. So again, immediately if you see this, this is not what you use in school. So the school formula is different because the sign convention is different. In the Gaussian sign convention, this is the lens equation. Okay, 1 upon u plus 1 upon v is equal to 1 upon f. You know why I like this formula a lot? Because it emphasizes one very important property of light. Okay, light has this property of reversibility, which is very important. What is meaning of reversibility? That if a light ray travels from point A to point B, like if I have a light source at point A and the light travels from A to B, then I could imagine a reverse situation where I put the light source at B and the light ray goes back to A. Okay, the path of the light can be reversed. In the same way, here in the diagram, here the object is here and the image is here. But I can imagine a reverse situation where I put the object here and the image will get formed there. So the light ray is just tracing the same line but in the opposite direction. And in that case, what will happen to u and v? They will just get exchanged, right? Initially, if the u was here and v was here, after I put the object here, now this should be called u and this should be called v, right? And this the fact that the order of that does not matter. What you call u and what you call v doesn't matter is very clearly seen here that 1 upon u plus 1 upon v, I could write it as 1 upon v plus 1 upon u, right? Doesn't matter. So the fact that these two terms can be interchanged is so nicely shown by this equation. That is why I really like this equation. Okay, the other equation does not have this nice property. Like if I look at the Cartesian formula, it does not have the same property that here SO and SI, you cannot flip them. If you flip them, the equation will become invalid. So that is why this equation has this very nice property. Okay, so this is the Gaussian sign convention, and as we'll let's solve this problem, and you'll see how we apply this sign convention. But the formula is just this, that 1 upon u plus 1 upon v is equal to 1 upon f. Okay, and then there is one more formula for the uh, size of the object also. So that is just, if you look at the diagram, you have similar triangles, right? If you have a object over here of, let us say, the height of the object is given as ho, and the height of the image is given as hi. Okay, so height of the image, so hi, and height of the object is ho. Then you'll see that I'm just going to get similar triangles, right? These two triangles have the same angles. So therefore, I can write the corresponding ratios, and I will get ho upon hi is equal to u upon v. Okay, so these two formulae, the ratio of the sizes of the object and the image, and the length equation, these together are sufficient to solve all these questions. Yes, Harish?
Sir, we have length formula as 1 by v minus 1 by u now.
That is what I'm saying. That is the coordinate sign convention. But in the
Yes.
Gaussian sign convention, this is the formula.
Yes.
But again, if your doubt is that will this convention give you a different answer in the end, the answer is no. That finally you'll get the same answer. Just that in the intermediate calculation will look different because some of the signs are negative instead of positive. But at the end, you should get the same final answer.
Yes, sir.
Okay. And again, I mean, I'm asking you to change your point of view that, yeah, start using the Gaussian sign convention. It will make things very, very easy for you when you start studying JEE optics. Because see, here the question is very simple. There is just one convex lens. So there is not a lot of scope for confusion. But in a JEE question, you'll have 3, 4 lenses, mirrors, with some complicated arrangement. And it can be very easy to lose track of which object is where, and the sign convention will help you to make things clear. Okay, so let us see what is question 19. Image of an object is real and twice the size of the. So let us draw the diagram that, let us say the lens is here, and so what it is saying, the image is twice the size of the original object. Okay, so if the original object is of hi, then ho is twice of hi. Okay, so immediately you see that if I use the labels u and v, um, then by similar triangles, you see that the ratio u upon v will also be of the same, right? U upon v will be also hi upon 2 times hi. Or in other words, if I rearrange this, I'm going to say that v is twice of u, right? Okay, and I can write the length equation, right? So here the length equation is 1 upon u plus 1 upon v is equal to 1 upon f. But now because v is 2 times u, instead of v, I can write it as 2u. So I'll get 1 upon u plus 1 upon 2 times u is equal to 1 upon f. Okay. And so this was one situation. And then what are they saying? When the object is moved towards the lens by 20 centimeter, its image is, oh, sorry, I did not read the question properly. Oh, no, yes, correct. Okay. If the object is moved towards the lens by 20 centimeter, its image is virtual and twice the size of the object. Okay. So now what is happening in the new picture, the lens is in the same position, but the object is moved 20 centimeter closer. So now in my new situation, the object is now 20 centimeter closer. So let us say the object is here now. So in compared to here, the object is moved forward by 20. So now this distance is now u minus 20, right? And now the image is virtual. So what is the meaning of virtual image? It is found on the same side like this, and it is twice the size of the object. Okay, so now again, this distance, right, from the lens to my object, it will be twice this u minus 20. So I can write this as 2 times u minus 20. Okay, and now again I have to write the lens equation, but now this time remember that if I go back to my convention, what does the convention say? That if the image is if the image is real, then use positive sign. If the image is imaginary or virtual, use a negative sign. Or not imaginary is the wrong word, virtual. So virtual objects should have negative sign. So if the magnitude of this distance is 2 times u minus 20, the when I write the lens equation, so if I write 1 upon u plus 1 upon v, so when I'm writing v, I have to remember the sign has to be flipped. So I'll write it as 20 minus u. Okay. So again, understand why this sign got flipped, because the image is virtual. Okay. And so now I have two equations and two unknowns, right? So I can solve and get the value of u and f. So let me just do that quickly. So from the first equation, I can rewrite it as 2 upon 2u plus 1 upon 2u is equal to 1 upon f. So 3 upon 2u is 1 upon f. So u is 3f by 2. Okay. And if I substitute that in the second equation, in fact, let me just rearrange the second equation first. So I'm getting 1 upon u minus 20 minus 1 upon okay. So I want to get 1 upon u minus 20. But in other words, 3f upon 2 is u minus 20. Oh, sorry, wait, I made a mistake here. So when I take the LCM, so denominator 2 minus 1 is equal to 1 upon f. Okay, so therefore I'm going to get okay. So this is the simplified version of both the equations. And so if I combine the two, I can eliminate u, right? If I substitute u from here in this equation, I'm going to get f upon 2 is equal to 3f upon 2 minus 20. And so I can find the value of f. It is simply going to be 20. And I think that is what we are asked to find, right? In the question. Yeah, calculate the focal length of, yes. Okay, so let me again focus on the sign convention part, because I can understand maybe it is confusing. So again, first situation when the object was real. So object was real. So therefore, this distance is whatever was u was taken as it is here. And the image was also real. So therefore V was taken as it is. So there was no sign change in this part. But in the second part, the object is still real. So this is U minus 20, but the image is now imaginary. So I have to flip the sign. So I, instead of taking, so if the value of this distance is 2 times U minus 20, the along with the sign, it becomes minus of that. So 2 times 20 minus U. And then finally, when I wrote this term over here, I took that minus sign out into the equation so that the denominator is again written as U minus 20. Uh, Prasanna, do you have any? I think I made a mistake in the equation, but I fixed that, right? Okay, so I think we are out of time. So that remaining, there is one more question on the lens equation, which we will discuss next time. And of course, the practice paper. Again, if you have any doubts about this, go to the that Wikipedia page which I showed, and
Hello, sir.
that table will like, yes.
At the start of the class, you have given some instruction about the exam. What were that?
So basically, what you should do is, so I will share the paper with you after the exam, our lecture is done. Solve the paper in a timed manner first, like it is a 1 hour exam, so 10 questions in 1 hour. So first do the paper in that way, and after you have done with that, try the paper once more. Where did I write? Okay. So try the paper 2 times. First with time limit, like give it like a proper exam, mock exam, and then do it without time limit. And just check that if without time limit you are able to do all the questions, then at least your theory is perfect. Like you don't have any problem with the theoretical aspect of it. But if you are not able to do it within the time, which means that you have to focus more on problem solving practice. Make sure that you have the formula sheet prepared and things like that. Oh yeah, that was the only thing I said.
And sir, will you provide a recording of this class to us?
No, we will not provide recording of the class.
Sir, if we want to see the previous lecture, so how we can?
So I mean, did you attend the Thursday's lecture?
Yes, sir, I have attended.
Yes. So I mean, this is supposed to be like a live classroom, right? So all the doubts we are solving in live session only. So we typically do not provide the recordings. We will put them on YouTube, but we don't do it immediately. We generally do it after maybe a few weeks. So by that time, your exam is already completed.
Yes, sir. Thank you, sir.
Yeah. Yeah. Okay. I think that's all for today. Thank you.
Thank you,
So
sir.
Thank you. Bye.
bye, sir.